Welcome back to the Deep Dive. Today, we're really embarking on a journey into the future of AI, or maybe more accurately, how you can build that future. You've already done fantastic work, building customer support chatbots, getting really good with prompt engineering. That's a great foundation. Now, imagine taking those skills a step further, truly empowering your AI to act, to think, and even to self-correct, especially in areas where precision, reliability, and empathy are just absolutely crucial. We're talking about moving beyond those sort of reactive responses to building genuinely intelligent adaptive systems.
Exactly. We're shifting the focus here, moving away from just static one-and-done interactions towards the architectural patterns that let your AI actually learn, refine its own work, navigate really complex challenges. This is all about giving your Python AI solutions the robust backbone they need to tackle some of the most sensitive and intricate problems you can imagine.
Okay, so our mission today is to unlock some of these really powerful concepts from the Agentic Design Patterns book. We're focusing on 4 key ones: reflection, tool use, planning, and multi-agent collaboration. Think of this deep dive as your next step, really. Moving you from being a proficient prompt engineer, which is great, to becoming an architect of these more sophisticated, self-improving agents. We're going to break down these new key concepts, the technical terms, the architecture behind it all, in a clear, engaging way, hopefully making the learning pretty smooth and intuitive for you. And we know your goal, your driving force, is this profound mission, creatively and efficiently supporting domestic violence crisis response organizations with AI. That's a mission that honestly demands the absolute best in AI capabilities. These patterns we're discussing, they are precisely what you need to build agents that aren't just smart, but deeply reliable, impeccably accurate, and profoundly effective in those critical real-world situations. We'll show you exactly how these insights apply to that vital work. Okay, let's unpack this first one then, reflections.
In previous deep dives, we've talked about things like chaining, routing, parallelization, all really useful ways to make agents run tasks more efficiently. But what happens when an agent's first shot at something isn't quite right? What if it misses a nuance or makes a small factual error?
That's exactly where reflection steps in. And it's a real game changer, honestly. It introduces this crucial feedback loop. It goes beyond just doing the task. So instead of just spitting out an output and moving on, reflection lets an agent, evaluate its own work, identify issues, and then use that evaluation to improve and refine its response. It's a form of self-correction. Basically, the AI thinking about its own thinking, if that makes sense. This lets the agent constantly refine its output or maybe adjust its approach, either through internal critique or by checking its work against the specific goals and standards you've set for it.
Right, so it's not just doing, it's critically examining its own performance. That sounds like a huge leap for quality control, doesn't it?
Yep. How
does this actually work then, under the hood? What are the key sort of moving parts in this self-correction loop?
Yeah, we can break it down into a few distinct but interconnected components. They form this kind of iterative loop, much like how a human might refine a piece of writing or code. First up, you have execution. This is where the agent performs the initial task, generates that first draft of its output, its first attempt. Next comes evaluation critique. And this is key. Here, the agent may be using another LLM call or perhaps a predefined set of rules. It rigorously analyzes that initial result. And this isn't just a casual glance, right? It's a deep assessment, checking factual accuracy, coherence, the writing style, completeness, and really importantly, strict adherence to any specific instructions or sensitive constraints you've given it. Okay, so based on that critique, we get into the reflection refinement stage. The agent then figures out how to improve. This might mean generating a whole new refined output, or maybe adjusting some internal parameters for the next step, or even modifying its overall plan for future actions. It's genuinely learning from its mistakes, so to speak. And while it's optional, iteration is super common and really powerful here. The refined output or the adjusted approach can then be executed again, right? And the whole reflection process can repeat. It keeps going until a satisfactory result is achieved, or maybe a specific stopping condition is met, like a human signs off on it, or the critique finally says, code is perfect. This iterative loop is really what pushes the agent towards higher and higher quality, more polished outcomes.
That idea of an agent critiquing its own performance, that's already a big deal. But then the source material brings up this generator critic or producer reviewer model. And honestly, that kind of clicked things into place for me even more. Why is separating these roles so powerful? Doesn't adding a whole separate critic agent, like, introduce more overhead, maybe more complexity than it's worth, especially if you're working on something less critical?
That's a really fair question, and it gets right to the heart of why this pattern is so robust, actually. What's fascinating here is that this separation largely prevents something we might call cognitive bias. I mean, think about it. How many of us really enjoy proofreading our own emails, like right after writing them? It's tough. We tend to see what we meant to write, not always what's actually down on the page. And maybe surprisingly, LLMs can show a similar kind of blind spot when you ask them to critique their own immediate output. So by having a distinct producer agent focused only on generating content, whether that's code or a plan or a message, it can just focus all its energy on that creation. Then a separate critic agent steps in, and you give this critic a completely different persona, different instructions. Maybe it's a senior software engineer or a meticulous fact checker. This critic agent is dedicated only to finding flaws, suggesting improvements, providing structured feedback against specific criteria, accuracy, code quality, style requirements, whatever it is. This division of labor means the critic approaches the output with a fresh, unbiased perspective. And that leads to much more objective and robust feedback. The producer then uses that precise feedback to generate a new, refined version. So yeah, maybe a tiny bit more overhead, but for high-stakes stuff. That leap in objectivity and quality, totally worth it.
Okay, that makes a lot of sense. So the producer makes the draft, and the critic isn't just giving a thumbs up or down. It's providing specific, actionable feedback based on clear standards. And this is exactly what we need when we're aiming for that high-quality, sensitive output for something like crisis response, right?
Precisely. The LangChain example in the source material shows this by using a reflector prompt. It essentially creates and activates that critic persona within the LLM, giving it the instructions, putting the reviewer hats on it. And similarly, the 80K example explicitly defines separate producer and reviewer agents. It's a really powerful structure, this two-agent model, for enhancing objectivity and getting that thorough, unbiased evaluation.
Understood. Okay, so how does reflection then connect with the broader architecture of these agentic systems? What else should we be thinking about when we're building these smarter agents, especially for a mission as critical as, say, domestic violence crisis response?
Yeah, that's a really important question. How does this fit into the bigger picture? Its effectiveness gets a significant boost from two other key patterns: goal setting and monitoring, which is covered in Chapter 11 of the book, and memory from Chapter 8. Think of it like this: having a clearly defined goal, that gives the agent the ultimate benchmark for its self-evaluation. It lets the agent objectively assess if its output is actually moving towards the desired outcome. Monitoring, then, tracks its progress, giving reflection that dynamic feedback mechanism. Without those, reflection is kind of working in a vacuum, right? No clear target, no way to measure improvement, and maybe even more importantly, its power is dramatically amplified by memory. Reflection without memory is like, well, learning from your mistakes, but then forgetting the lesson the very next day. With memory, the LLM keeps a record. Past interactions, previous critiques, maybe even evolving goals. This conversational history provides crucial context for that evaluation phase. It lets the agent assess its output not just in isolation, but against the backdrop of everything that came before. It learns from past critiques, avoids repeating errors. Without memory, each reflection is just a one-off. With it, reflection becomes this cumulative learning process. Each cycle builds on the last, leading to a truly intelligent, self-evolving system that keeps improving its decisions and output based on experience.
That's a really profound insight. It really does transform the agent from just a passive executor into something more like a purposeful system, adaptively working toward its goals. Okay, let's bring this right back to your mission. How can the reflection pattern specifically help in supporting domestic violence crisis response organizations with AI? This is where the rubber really meets the road.
Yeah, this pattern is incredibly valuable in those scenarios where output quality, accuracy, and sticking to sensitive constraints are just paramount. First, think about refining critical communications. Imagine an agent drafting an initial support message or maybe an information summary for someone in crisis, or even a public statement. The reflection pattern lets the agent generate a draft, then critique it rigorously for tone, clarity, completeness, and critically strict adherence to safety protocols. It could ensure the language is empathetic, non-judgmental, provides accurate, vetted resources, and then refine it, iterate on it until it meets the absolute highest standards. This ensures the content is polished, effective, and most importantly, safe and responsible.
That's huge. I mean, ensuring the tone is right, that it's not accidentally triggering someone or giving incomplete information that could literally save lives, prevent re-traumatization.
Absolutely, it's foundational. In these situations, even a small misstep can have huge real-world consequences. That's why reflection is so vital. Now, that helps ensure the external face of your AI is polished, but what about the internal engine, the tools it relies on? Can reflection help there too? Yes. Consider code generation and debugging. If your AI is maybe generating Python scripts for data analysis, perhaps, to quickly spot trends in call data or look up resource availability based on dynamic criteria, reflection can help. It can write the initial code, run simulated tests, identify errors or maybe inefficiencies, and then modify the code itself. This helps ensure the underlying tools for crisis response are robust, functional, preventing glitches right when they're needed most.
So it's not just for the outward-facing stuff, but for the internal mechanics, too. That's powerful. And what about handling the sheer volume and complexity of information that flows into these organizations?
That's another critical point. For summarization and information synthesis, imagine an agent processing a long intake form or a complex policy document, maybe legal guidelines. Accuracy here is non-negotiable. Reflection lets it generate an initial summary, then compare it against key points for accuracy and completeness, and then refine it. This helps ensure crucial information isn't missed or misinterpreted, which is vital in a crisis where details matter, and human responders rely on condensed, accurate briefings. And finally, for conversational agents, like a support chatbot, reflection lets it review previous turns in the conversation. This helps it maintain context, correct misunderstandings, improve response quality. After a user message, the agent can look back at its last response, maybe the whole conversation history, ensure coherence, make sure it's accurately addressing the user's latest input. This leads to more natural, more effective, and crucially safer conversations, especially when dealing with sensitive, evolving situations where context is absolutely everything.
Okay, so you've got about 6 months of Python experience under your belt. These code examples from the book, they're really designed to make these concepts click. Let's look at how this actually plays out in, real Python code.
Right. The source provides two key examples that illustrate this pattern really well. The first one is the LangChain example, focusing on iterative code refinement. This demonstrates a multi-step reflection loop designed to improve a Python function, specifically one that calculates a factorial. The process involves defining a task prompt for the initial code generation. Then it enters an iterative loop. You set max iterations. In this loop, the LLM first generates the code, then in the next iterations, it refines it. And to make that LLM act like a senior software engineer, you craft a reflector prompt. It literally starts with instructions like, you are an expert Python developer meticulously reviewing code. Identify bugs, style violations like PB8, edge cases the code might miss. Provide specific, actionable feedback, or state code as perfect if it's good. It's about explicitly giving the AI that role, those precise instructions, just like briefing a human reviewer. And crucially, message history is maintained throughout the process. That provides context for each refinement step, letting the agent remember past critiques.
That's a perfect real-world application for a beginner to see. It's not just writing code. The AI is actively improving it.
Exactly. For your work, think about an agent that needs to generate a Python script, maybe to quickly pull relevant local support services based on a user's anonymized location. This reflection loop could ensure that script is accurate, handles various edge cases like invalid input or no services found in that area, adheres to best practices, preventing errors in a time-sensitive situation where reliability is absolutely key. The second example is the ADK example, showcasing a generator-critic structure. This illustrates a conceptual pipeline. You have a generator agent writes an initial draft paragraph. Then a reviewer agent, specifically acting as a meticulous fact-checker, evaluates that draft text for accuracy. Its output is structured, maybe a dictionary with a status like accurate or inaccurate, and detailed reasoning. A sequential agent then orchestrates this whole flow, making sure the generator runs before the reviewer gets it.
Right, so this is a clear demonstration of that producer-reviewer model we were just talking about. It shows how you can literally code that interaction between two specialized agents.
Absolutely. For your mission, imagine an agent generating policy summaries or safety tips for crisis situations. This ADK example clearly shows how a second, specialized agent could step in to fact-check or ensure compliance with safety protocols. It feeds back that structured critique before the information reaches a human or gets disseminated further. That structured feedback is invaluable for high-stakes info, where, getting it right the first time often isn't really an option.
This sounds incredibly powerful for ensuring quality. But, like always, there have to be trade-offs, right?
Right.
What are the considerations we need to keep front of mind here?
Absolutely. While reflection significantly boosts output quality, accuracy, and adherence to complex instructions, it definitely comes with costs. That iterative process, powerful as it is, means each refinement loop typically needs a new LLM call. This can lead to higher costs and increased latency, which might make it less ideal for extremely time-sensitive applications where immediate speed is maybe more important than absolute perfection. Furthermore, it's quite memory-intensive. With each iteration, the conversational history grows the initial output, the critique, the refinements. This accumulation carries a risk of hitting the LLM's context window limits, or maybe facing API throttling from your language model provider if you're not careful managing it.
So the core insight here isn't just about the technical cost, right? It's about a strategic decision. Are we prioritizing immediate speed, or are we prioritizing meticulous, potentially life-saving accuracy? When is that trade-off really worth it for our mission?
Precisely. The rule of thumb is: use reflection when quality, accuracy, and detail are absolutely paramount, more so than raw speed or cost. It's especially good for polished content, mission-critical code, or detailed plans that require basically zero tolerance for error. And definitely consider leveraging a separate critic agent for maximum objectivity. It's about making that deliberate choice where the benefits of self-correction and enhanced reliability outweigh the operational overhead. And in crisis response, that's often going to be the case.
Okay, let's move on to tool use then. So far, our agents are pretty smart internally. With reflection, they can even self-correct. But they're still kind of living in a bubble, aren't they? They can only operate on the data they were trained on or whatever we've given them directly in the prompt. How do we get them to actually, do things, interact with the real world?
That's a perfect way to put it. LLMs are incredibly powerful text generators, amazing at understanding and producing human language. But their knowledge is static, right? It's frozen in time by their training data. They can't access real-time information. They can't perform complex, deterministic calculations like precise math or logical operations reliably. And they can't directly interact with external systems like databases or web APIs. The tool use pattern, often implemented through something called function calling, is that essential bridge. It allows an agent to break out of that bubble and interact with the real world, whether that's querying external APIs, searching databases, invoking web services, or even executing specific code in a controlled environment. It transforms the LLM from just a static knowledge base into an active participant that can sense, reason, and act in the digital world, or maybe even the physical world eventually.
And the source mentions tool calling versus function calling. Is there an important distinction there for someone like, our listener who's just getting started with this?
That's a great question. And yeah, there is a subtle but kind of important distinction. While function calling really aptly describes the technical mechanism invoking specific predefined code functions, like calling a Python function you wrote tool calling, is broader. It's a more expansive concept. It acknowledges that an agent's capabilities can go way beyond just simple code execution. A tool can definitely be a traditional code function, yeah, but it can also be a complex API endpoint, a request to a database, or even an instruction aimed at another specialized agent. For instance, a main agent might use a tool that delegates a complex data analysis task to a dedicated analyst agent, or it might query an external knowledge base through its specific API. Thinking in terms of tool calling better captures the full potential, Agents acting as orchestrators across this diverse ecosystem of digital resources and maybe even other intelligent entities. It's about defining a capability the agent can leverage, not just a function it can call.
Okay, that makes a lot of sense. It definitely broadens the scope quite a bit. So how does the agent actually decide to use a tool? And then how does that get executed, like step by step?
Yeah, the process typically involves a few key steps, and the source material has a nice visual summary of this. First, there's tool definition. This is where you clearly describe these external functions or capabilities to the LLM. This description is vital. It includes the tool's purpose, its exact name, the parameters it accepts, their types, clear descriptions. Think of it like giving the agent a detailed instruction manual for each tool it has access to. Next, the LLM decision phase. The LLM gets the user's request and evaluates it against all the tool definitions it knows about. Based on its understanding of the request and the tool's capabilities, it intelligently decides if calling one or more tools is necessary to actually fulfill that request. If it decides, yep, I need a tool for this, it moves to function call generation. The LLM outputs a structured call, often in JSON format, specifying the name of the tool to invoke and the arguments, the parameters to pass to it. It carefully extracts these from the user's request. Following that, the tool execution phase takes over. Your agentic framework, your orchestration layer, intercepts the structured output from the LLM. It identifies the requested tool and actually runs the external function with the arguments provided. The result of that is the observation result. The output from that tool execution gets returned back to the agent. Finally, in the LLM processing stage, the LLM receives the tool's output as additional context. It uses this new information to formulate a final informed response to the user, or maybe decide on its next steps, which might involve calling another tool, reflecting on the outcome, or giving a definitive answer. This whole cycle is what lets agents perform actions and get dynamic information beyond just their training data.
Now, for someone building AI for domestic violence crisis response, connecting to the real world is absolutely non-negotiable, right? This isn't just about general info. It's often about providing real-time, potentially life-saving resources. How does tool use make that possible in such a critical domain?
This pattern is absolutely fundamental for such a sensitive area. It enables agents to provide timely, accurate, and truly actionable support. First, think about information retrieval from external sources. Imagine an agent needs to provide real-time, localized support resources. A tool here could be an API connected to a vetted, constantly updated database of local shelters, legal aid organizations, or emergency services. The agent flow might look something like this. A user asks, "Where can I find a safe shelter near me?" The LLM intelligently calls the tool, passing the user's anonymized location. The tool then queries the database and returns a list of up-to-date verified resources. The LLM then formats this into a safe, empathetic, and actionable response. This capability goes way beyond static FAQs. It's dynamic, personalized, context-aware assistance.
That's a critical difference, yeah. Knowing where to go right now, today, is what matters most in those situations.
Exactly. Another crucial application is interacting with databases and APIs. Many crisis response organizations have their own internal knowledge bases or systems for tracking ongoing cases, always with strict privacy and security controls, of course. Tools could be secure API calls to query these internal databases, maybe for specific support protocols, previous interactions, anonymized and permission controlled, naturally, or perhaps to check the availability of human specialists. For example, an agent needs to check if a user has previously contacted the service. It calls a secure internal database API, retrieves anonymized interaction history, and uses that context to inform the current response. This ensures continuity and appropriate tailored care without forcing the user to repeat potentially re-traumatizing details.
And in a crisis, timely communication is just paramount. Can tools help with that side of things too?
Absolutely. Sending communications or alerts is a vital use case. In a high-stakes situation, timely, secure communication is essential. A tool could be a secure API for sending encrypted messages, maybe setting up emergency contacts with explicit user consent always, or flagging critical cases for immediate human intervention. An agent flow might involve a user indicating a high-risk situation. The LLM, after confirmation and consent, calls an internal alert tool. This immediately notifies a human crisis responder, while the agent simultaneously drafts a reassuring interim message to the user. It manages the situation with both speed and careful communication.
That proactive notification, that's a huge potential game changer for human responders trying to manage caseloads. What about more complex data processing or calculations that an LLM might, struggle with reliably?
For that, we turn to executing code. Sometimes you need specific deterministic logic or complex data processing that goes beyond what an LLM can reliably do on its own. A tool could be a sandboxed Python interpreter. It could handle complex data transformations, validation like checking phone number formats or addresses, or maybe run specific algorithmic calculations like immediate risk scores based on predefined validated algorithms. For instance, an agent receives complex intake data. It might use a code interpreter tool to validate phone numbers, parse addresses, calculate those immediate risk scores using validated algorithms, ensuring data integrity and providing a rapid initial assessment before a human even reviews it. This ensures critical data is handled precisely and reliably.
Okay, so how do these tools actually get built and integrated into our Python code? For someone with, say, 6 months of Python experience, seeing how these frameworks handle it would be really useful.
Yeah, that's a perfect bridge. Frameworks like LangChain, CrewAI, and Google ADK provide really robust support for defining and integrating these tools into your agent workflows. They often abstract away a lot of the underlying complexity. Let's look at some examples from the source material. The LangChain example demonstrates a simulated search tool. The code defines a regular Python function called search information, but it's decorated with LangChain tool. This @LangChain tool decorator is the key piece. It registers your Python function as something the LLM can discover and decide to use. This specific tool just simulates fetching facts, like weather or capital cities, from a predefined dictionary. The example then shows how to create a create tool calling agent and an agent executor. These components make the LLM decide when and how to use the search information tool based on the user's prompt. Your takeaway here as a Python beginner is that this teaches the basic structure. Define a custom tool, essentially any Python function you write, and let an agent intelligently use it. You can easily adapt this search information function. Just replace the dummy data with actual API calls to query your specific crisis support database for protocols, local resources, or vetted information.
That seems like a really clear first step for someone wanting to connect their AI to, say, a database of local legal aid contacts, or maybe checking available shelter beds in real time.
Exactly. Then there's the Crew AI example, which simulates a stock price lookup. This shows how to define an @tool decorator, conceptually very similar to LangChain's called getStockPrice. And then it integrates it directly into a specific agent, a financial analyst agent. A task is then created that explicitly instructs this agent to use the tool. What's valuable here is that it also highlights robust error handling within the tool itself. It raises a value error if a stock ticker isn't found. Your takeaway is this. It's a very clear example of how to equip an agent with a specialized function, give it a goal, and critically, how to handle both success and failure outcomes gracefully. This prepares you to build tools for specific crisis response actions, like looking up resource availability, checking operating hours, and knowing what to do if that information isn't available.
And what about Google ADK? The source mentions it has some pretty powerful built-in tools available.
Yes, Google ADK offers natively integrated tools, which can really streamline development, especially if you're already in the Google ecosystem. First, there's Google Search. An ADK agent can be configured super simply, just tools, Google Search, to perform web searches. Your takeaway. This could be crucial for an agent to quickly gather publicly available up-to-date information. Maybe recent policy changes from government websites or verifying general info about a local service, like a clinic's operating hours or contact details that might change frequently. It saves significant manual research time and ensures currency. Next, ADK offers built-in code execution. An L agent can be given a code executor, built-in code executor. This lets it write and execute Python code for calculations or data manipulation, all within a sandboxed environment for safety. Your takeaway. This allows your agent to perform that deterministic logic we talked about. Think of it as an AI-powered calculator or data processor. Tasks like calculating the shortest, safest route to a safe house considering real-time traffic, or processing complex structured data from intake forms to extract key risk factors based on specific rules. This ensures precision, where an LLM alone might hallucinate numbers or struggle with complex logic.
That's a great example for something like a dynamic risk assessment tool that really needs precise calculations. What about for organizations with their own private sensitive data? Stuff that shouldn't be out on the public web.
Right. For organizations with large internal knowledge bases or proprietary data, ADK has the Enterprise Search vSearch agent. This agent uses Vertex AI Search Data Store to answer questions by searching private specified data. This is incredibly powerful for your mission. Your agent could search sensitive internal documents, specific crisis protocols, legal guidance, maybe anonymized historical case data, ensuring the information provided is always accurate, relevant, and controlled. It maintains strict data access policies. It basically extends the agent's knowledge to include your organization's specific vetted information, which is absolutely critical for consistency and compliance.
Okay, the source also mentions Vertex extensions.
Yeah.
How does that differ from the function calling we've just discussed? Is it just another name for basically the same thing?
That's an important clarification to make. Vertex AI extensions are structured API wrappers designed specifically with enterprise-grade security and data privacy in mind. They live within the Vertex AI ecosystem. Now, while both function calling and extensions facilitate those external interactions, the key difference is really in their execution and management. With Vertex AI extensions, when the LM decides to use an extension, Vertex AI automatically executes it. It handles the invocation seamlessly right there within the platform. In contrast, standard function calls, like we saw with LangChain or Crew AI, typically require your code, your client framework, to manually execute the function after the LLM generates the call request. Extensions offer strong enterprise controls, potentially easier deployment, and seamless integration with other Google products. This makes them potentially ideal for production environments where security, scalability, and manageability are top priorities, particularly if you have existing Google Cloud infrastructure.
Okay, that makes a lot of sense for a more robust, maybe larger scale production environment.
Yeah.
What's the downside then? All this power to connect to the outside world. There has to be a trade-off, right?
Absolutely. Like reflection, tool use definitely adds layers of complexity. While it vastly extends an agent's capabilities, it also introduces dependencies on those external services. This means you have to account for potential API rate limits or maybe service outages from those external providers you're relying on. There's also the crucial need for robust error handling within your own code. Because external calls can, and frankly will, fail sometimes. Network issues, invalid inputs, service downtimes. Your agent needs to be able to recover gracefully from that, or at least inform the user clearly when these failures happen.
So it's really about managing those external dependencies, ensuring the entire system is resilient, not just the AI part itself.
Exactly right. You're building a connected system, and each one of those connection points needs careful thought and handling.
All right, so we've got agents that can self-correct with reflection and interact with the real world using tools. Those are huge steps. But how do we get them to tackle the really big, multi-step problems? Things that aren't just a single command, but require a whole complex strategy to solve.
That's where the planning pattern comes in. And it's really a hallmark of truly intelligent behavior, moving beyond simple reactivity. Often an agent needs more than just reacting to the immediate input. It needs foresight. Planning is all about an agent formulating a sequence of actions, a strategy, to get from an initial state to a desired goal state. You define what the objective, maybe some constraints, and the agent figures out the how. It's about adapting to new information as it comes in, steering around obstacles, not just blindly following some rigid, predefined script we gave it. The plan itself isn't known in advance. It's created dynamically by the agent in response to the request.
So it's kind of like giving an AI a high-level mission statement, like support this survivor to safety and stability. And it figures out all the granular individual steps needed to actually achieve that.
Precisely. And a really crucial aspect of this process is its adaptability. An initial plan is just that, a starting point, not some rigid script carved in stone. The agent's real power, as the source material emphasizes, is its ability to take in new information and steer the project, if you will, around obstacles. For instance, if maybe a preferred resource suddenly becomes unavailable or new information about a user's immediate safety comes to light, a capable agent doesn't just fail or stop. It adapts. It registers that new constraint, reevaluates its options, and formulates a new, revised plan. This makes planning a core computational process in autonomous systems. It lets them navigate dynamic, unpredictable environments, much like a human project manager adapting to changing circumstances on the fly.
That adaptability is just critical for real-world problems, isn't it? Especially in crisis response, where situations can literally change in an instant. What's the core question we should ask ourselves to know if planning is the right pattern for a particular problem we're trying to solve?
The crucial question, as the source highlights, really boils down to this. Does the how need to be discovered, or is it already known? If the solution path is well understood, linear, repeatable, essentially a fixed set of instructions, then a simple workflow, maybe just chaining steps together, is often more efficient. But if the how needs to be dynamically charted, adapted, potentially reevaluated based on unfolding circumstances or new information, then planning is your answer. It's about empowering the agent to autonomously chart a course when the path isn't clear right from the outset.
Planning seems absolutely essential then for handling the nuanced multi-stage support that crisis response requires. These aren't usually just single-step processes.
Absolutely. This pattern transforms a high-level objective into a structured, executable plan, which is vital in complex and sensitive domains like this. Consider procedural task automation. Maybe automating a complex intake process for a crisis responder. An agent could plan to collect initial details, then assess immediate risk factors, maybe using a dedicated tool, then look up appropriate legal resources, then generate follow-up questions for clarification, and maybe even schedule a human callback if needed. Each step is orchestrated in a logical sequence, invoking necessary tools or interacting with various systems as it goes. This ensures a comprehensive and consistent approach to what can be a potentially chaotic initial interaction, and it reduces the burden on human staff.
That's a huge benefit for busy organizations, right? Ensuring no critical step gets missed and that responders have all the necessary information efficiently laid out for them.
Indeed. Another really powerful application is structured information synthesis. Think about generating a comprehensive briefing for a human crisis responder based on maybe diverse inputs. The agent could plan distinct phases. First, information gathering from internal databases, external tools maybe, then data summarization to pull out the key points, then content structuring, like creating logical sections, immediate safety concerns, emotional support needs, resource gaps, and then critically, iterative refinement using the reflection pattern we discussed earlier. This ensures a complete, well-organized, and accurate report gets delivered, not just a jumble of raw data. It allows human responders to quickly grasp complex situations.
That sounds like it would save human responders an incredible amount of time, allowing them to focus on the direct support, the human connection, rather than just sifting through piles of information.
Precisely. And finally, for multi-step problem resolution, guiding a user through a complex support journey often requires more than just a single response. An agent could create a systematic plan, maybe starting with diagnosis, are you in immediate danger, then moving to solution implementation, here are emergency contacts and immediate safety steps. And perhaps finally, escalation. I'm connecting you with a human specialist who can help further. And crucially, it adapts this plan as the situation evolves based on user input or new information, ensuring a coherent and supportive journey through what might be a very difficult and confusing time for the user.
Okay, let's look at how frameworks help agents build these plans. For our listener with Python experience, what do these code examples actually look like in practice?
Right, the source illustrates this pretty well. First, the Crew AI example with an article planner and writer. This clearly demonstrates how you can instruct an agent to plan first. Here, a planner-writer agent is given a task that explicitly says, first, create a bullet point plan for an article, and then write the summary based on your plan. The expected output is clearly defined with two distinct sections, ##plan and ##summary. Your takeaway here, as someone with Python experience, is seeing how an agent can be explicitly told to plan first before acting. For your working crisis response, an agent could, say, plan a detailed safety assessment workflow, outlining all the critical questions and information gathering steps, and then execute that plan. Or it could plan a multi-step resource allocation process, making sure all dependencies are met before suggesting actions to a user.
That's a really practical way to ensure thoroughness and structure in those complex multi-step tasks. What about even more advanced planning, like for deep research that goes way beyond just planning a single article?
That brings us to things like Google Deep Research and the OpenAI Deep Research API. These are really advanced agent-based systems that fully embody this planning pattern. They move beyond simple task execution into autonomous information discovery and synthesis. How they work is fascinating. They take a high-level query, like the example in the source, what is the volume of VC investment in Europe and the countries that are accelerating? And they dynamically, iteratively query Google search to systematically explore complex topics. They actually deconstruct that initial prompt into a multi-point research plan. And this plan can even be reviewed and modified by a user, offering this sort of collaborative shaping of the research direction. The agent actively identifies knowledge gaps, corroborates data from numerous sources, resolves discrepancies it finds, ultimately generating a structured, multi-page summary complete with citations. The source even shows a figure illustrating how the plan is executed, using Google search as a tool repeatedly, leading to that comprehensive report.
Wow, that sounds like it can tackle some serious information overload. Sifting through potentially vast amounts of data. What about transparency in such a complex, multi-step research process? Can we actually see what the AI is doing under the hood?
Yeah, transparency is a key feature, especially noted with the OpenAI API. It specifically exposes all the intermediate steps. You can see the agent's reasoning process, the exact web search queries it executed, even any code it might have run to process data. This allows for detailed debugging, a deeper understanding of how the final answer was constructed, and ultimately builds trust in the system's output. Both systems are also noted as being highly extensible. They can integrate user-provided documents or connect to private knowledge bases, letting you blend public web research with your own proprietary information.
This is really next-level stuff. How would this apply to supporting domestic violence crisis response? What's the sort of aha moment here for that specific mission?
The aha moment here is potentially transformative, I think. Imagine needing a comprehensive background report, maybe on local domestic violence statistics in a specific city, or available legal aid services and their exact eligibility criteria, or perhaps a detailed breakdown of best practices for specific intervention types based on the latest research. A deep research agent could potentially plan and execute this entire research task for you. It could synthesize information from hundreds of public and maybe private sources into a structured, verifiable report with citations. This could save countless hours of manual work and ensure robust, evidence-based information is readily available for crisis responders. It takes proactive information gathering to a whole new level, providing deep, actionable context that can inform strategic planning and also immediate, potentially life-saving responses.
Okay, any cautions when implementing planning? This sounds incredibly powerful, but maybe also quite complex to set up and manage.
You're right to ask. Planning, especially dynamic planning where the agent is constantly reevaluating and adapting its steps, definitely introduces complexity. It can be more computationally intensive than just running a fixed workflow. The trade-off you're making is essentially between flexibility, the ability to adapt to unknown paths and unforeseen obstacles, and predictability guaranteeing consistent, simple outcomes every time. You should really lean towards planning when the how needs to be discovered and when the problem is complex enough that a predefined static script just wouldn't cut it. If the path is always the same, a simpler workflow might actually be better and more efficient.
So it's a really powerful tool, but one that needs to be deployed thoughtfully for the right kind of problem where that true adaptability is actually required.
Exactly. It's about empowering the AI for genuine, intelligent problem solving, not just rote task execution.
Okay, so we've seen how a single, really smart agent can self-correct with reflection, interact with the world using tool use, and even strategize complex goals with planning. But what if the problem is just too big, too complex, or requires so many different specialties that even one super agent can't handle it effectively?
That's the core idea behind multi-agent collaboration. And this is where AI really starts to mimic how human teams work, which is fascinating. It moves beyond trying to build one monolithic agent that knows everything. Instead, you create a cooperative ensemble of distinct, specialized agents. You break down a high-level objective into discrete subproblems, and each subproblem gets assigned to an agent that has the specific tools or data access or reasoning capabilities best suited for that particular task. This distributed architecture offers several big advantages. Enhanced modularity makes systems easier to build, update, and maintain. Scalability, you can add more agents for more complex tasks. And robustness, the failure of one agent doesn't necessarily bring the whole system down. The collaboration allows for this powerful synergy where the team's combined effort achieves far more than any single agent could possibly manage on its own.
So it's really like building a dream team of AI specialists, right? Each with their own unique expertise. That's a really interesting concept. But how do these agents actually work together? Do they just like shout across the digital room at each other?
Right.
Or is there a more structured way they communicate?
Not quite shouting, no. Structured communication is absolutely key. There are various models for how they interact, ranging from pretty simple to incredibly complex. Figure 2 in the source material actually visualizes several different agent communication structures, which is helpful.
Yeah, let's maybe walk through those communication structures because they really illustrate the different ways these teams can actually be put together in practice.
Certainly. The simplest is the single agent, which we've mostly discussed. It operates autonomously, does its thing, but its capabilities are limited by its individual scope. Then you have the network model. Here, multiple agents interact directly with each other, more like peer-to-peer decentralized. This can be really resilient, right? If one agent goes down, the others can potentially adapt. It's dynamic, but maybe complex to manage. The supervisor model is more hierarchical. You have a dedicated agent overseeing and coordinating subordinate agents. This gives clear authority and control, but it can also create a single point of failure if that supervisor agent falters. A subtle variation is supervisor as a tool. Here, the supervisor acts less like a rigid commander and more like a helpful resource or expert consultant. Other agents can query it for guidance or resources, but without that strict top-down control. For really complex problems, there's the hierarchical model. This expands on the supervisor idea into multiple layers. Higher-level supervisors oversee lower-level ones. This is great for problems you can neatly break down into sub-problems managed by different layers. And finally, there are custom models. This represents ultimate flexibility, maybe combining elements from these other structures or creating totally novel designs tailored to unique requirements. Allows for truly specialized solutions.
That gives a really great mental picture of the different kinds of team structures we could potentially build. Beyond these general models, what are the specific forms of collaboration we often see happening between these agents? How do they actually pass information or tasks?
Right, good question. They can collaborate in several ways. Sequential handoffs. This is pretty common. One agent completes its task and passes its output directly to the next agent in line for the subsequent step. Think of it like an assembly line for information or action. Parallel processing. Multiple agents work on different parts of a problem simultaneously. Then the results are combined later. This is incredibly efficient for tasks where speed really matters. debate, and consensus. You might have agents with varied perspectives, maybe different information sources, engaging in discussions to evaluate options. They aim to reach a consensus or at least a more informed decision. This can lead to more robust, well-vetted outcomes, hierarchical structures. As we mentioned, a manager agent might delegate tasks dynamically to worker agents based on their specific tools or capabilities, and then it synthesizes their results. Expert teams. Agents with specialized knowledge in different domains, maybe a researcher, a writer, an editor, collaborate to produce some complex output like a detailed report. And notably, the critic-reviewer model, which, as you see, links directly back to our reflection pattern. Here, one group of agents creates initial outputs, and a second group critically assesses this output, checking for policy adherence, quality, ethical alignment, correctness. Then the original creator, or maybe a final polishing agent, revises the output based on that feedback. This significantly increases robustness, reduces errors, helps mitigate things like hallucinations, especially for creative content or complex problem solving. This form is really effective for things like code generation, research writing, logic checking.
Okay, this is where your AI can truly become a force multiplier for a crisis organization, right? Extending its reach and capabilities exponentially. How can a team of agents specifically support domestic violence crisis response? Let's make it concrete.
Yeah, think about simulating a human team, but with AI speed and scale, potentially providing unparalleled support. For complex research and analysis, an agent team could gather comprehensive information that might take a human team days or even weeks. Imagine one agent specializing in searching legal databases for relevant statutes related to domestic violence in a specific jurisdiction. Another searches for local community resources and support groups, shelters, counseling, legal aid. And maybe a third agent summarizes all these findings into actionable points and concise briefings for a human responder. This ensures all relevant information is collected, organized, and digestible, allowing human staff to focus on the direct interaction, the human element.
That's incredibly powerful. It's like having a full custom research department available instantly, tailored to this specific need.
Absolutely. Then think about customer support escalation. You could have a frontline triage agent handling initial inquiries. It could quickly identify immediate threats or critical needs, asking things like, "Are you safe right now?" or "Do you need immediate medical attention?" If the situation is complex or requires specialized knowledge, the triage agent could then delegate the conversation or task to a specialist agent, maybe a legal resource agent or a safety planning agent, to provide deeper, more nuanced assistance. This demonstrates that sequential handoff based on problem complexity, making sure the user gets the right type of support at the right time from an expert AI.
That's a really structured way to provide multi-tiered support, just like a human team might, but potentially with instant handoffs.
Exactly. We could also apply this to network analysis and remediation. If the crisis involves online safety, maybe a survivor is experiencing digital harassment, agents could collaborate. One agent could specialize in monitoring for digital harassment, maybe using specific tools. Another could plan and execute reporting mechanisms to social media platforms or even authorities. And a third could draft safety recommendations or digital hygiene tips for the user to help secure their online presence. And finally, for creative content generation for awareness, a team could generate an entire campaign, maybe for public awareness or fundraising. You could have a market research agent identify key demographics and messaging strategies. A copywriter agent drafts empathetic and impactful messaging. And crucially, a fact-checker agent ensures all statistics and claims are accurate, responsibly presented, and ethically aligned with the organization's mission.
Okay, let's look at how frameworks help agents build these teams. For our Python-savvy listener, what do the code examples reveal about setting this up?
Right, the source material gives us some clear examples here too. The Crew AI example for blog post creation beautifully showcases this. It has a researcher agent finding AI trends and a writer agent creating a blog post based on that research. The research task and writing task are defined separately, and the writing task explicitly has context research task. This clearly establishes that sequential handoff. Your takeaway here is that this is a perfect blueprint for a crisis response team structure. Imagine one agent gathering all relevant facts about a situation, a fact-gatherer agent. Then a second agent, maybe specifically skilled in empathetic and trauma-informed communication, let's call it a communication agent, uses that information to draft a highly sensitive and supportive message or action plan for a survivor. The flow of information is clear, intentional.
That's a very tangible example, yeah. Showing how you build that pipeline of specialized AI functions. What about Google ADK? It seems like it offers diverse collaboration structures, not just these linear ones.
Indeed. ADK provides really fine-grained control for agent interactions, allowing for highly customized team structures. For a hierarchical agent structure, it demonstrates a coordinator Elm agent delegating tasks. It sends work to a greeter Elm agent and maybe a custom task executor agent. The coordinator uses its own instructions to intelligently route tasks to these specialized sub-agents. Your takeaway. This is powerful for building layered support. You could have a high-level case manager agent that delegates tasks, maybe to a resource lookup agent for local services or a communication draft agent for survivor-centric messaging. It manages the overall flow without needing to perform every single subtask itself.
That makes the overall system much more organized, right?
Yeah.
And probably more scalable, preventing any single agent from getting totally overwhelmed.
Exactly. ADK also provides the loop agent with condition checker. This shows a loop agent orchestrating a processing step and a condition checker. It keeps going until some status becomes completed. Your takeaway. Think about an agent needing to iteratively monitor for a safe condition, like repeatedly checking if a specified contact has been reached, or if a secure connection is established, or maybe repeatedly attempting a resource lookup until it's successful. This ensures persistence and condition-based stopping, which is vital in situations that might not resolve immediately.
That's resilience built right into the system, ensuring the AI keeps working towards a resolution, not just giving up after one try. What about that linear multi-stage processing, like handling an intake form step by step?
For those linear workflows, there's the sequential agent. It defines a clear linear process. Step 1, maybe step 1 fetch, provides output, perhaps saving it to session.state data. Then step 2, maybe step 2 process, picks up that data from the session state and uses it. Your takeaway. This is ideal for multi-stage information processing. Like an agent first fetches initial details from a user, and then a second agent processes those details to identify immediate next steps or required resources. It ensures a logical, step-by-step approach.
And for when speed is absolutely crucial, when multiple things need to happen all at once.
That's where the parallel agent comes in. It allows subagents like the example weather fetcher and news fetcher to run concurrently at the same time. They store their results in the session state ready to be combined. Your takeaway. In a crisis, speed matters immensely. An agent could simultaneously fetch emergency contacts, identify local safety protocols, and check for immediate threats or breaking news that might impact a situation. It combines all that information quickly to present a holistic picture to a human responder, or maybe directly to a user if appropriate.
And finally, the source mentions agent as a tool. That sounds like a meta concept, almost one agent actually using another whole agent as if it were just a simple tool.
It is, and it's incredibly flexible and powerful. The example shows an artist agent using an image generator agent, but wrapped in an agent tool as one of its tools. Your takeaway. This is all about building modular, reusable AI components. A primary crisis coordination agent could use a specialized risk assessment agent as a tool just to get a quick expert risk score based on inputs. Or it could use a safety plan generator agent as a tool to draft a customized safety plan based on information it has gathered. It treats the entire capability of another agent as just a callable function. This allows for deep nesting and specialization, making your main agent even more powerful by letting it leverage these expert sub-agents on demand.
Okay, so with more agents comes more.
Yeah.
Exactly. What's the catch?
Complexity, without a doubt. Designing and managing the communication protocols between agents, figuring out task allocation, ensuring coherence across multiple agents, that can definitely be challenging. Debugging can also be more involved because you're tracking interactions across several different entities rather than just following a single linear flow. However, the benefits in modularity, scalability, and the sheer ability to tackle truly complex, multifaceted problems often outweigh these challenges, especially when the task genuinely requires diverse expertise or parallel processing power. It really comes down to a strategic decision. When does the problem genuinely demand a team approach? Hashtag tag tag outrag outro.
Wow, okay, that was a really deep dive. We've journeyed all the way from an agent's ability to refine its own thoughts using reflection, ensuring that quality and self-correction, then to its power to interact with the real world through tool use, connecting it to vital real-time data and actions. We then explored its capacity to strategize complex multi-step goals with planning, allowing it to dynamically figure out the how when the path isn't clear. And finally, we looked at the synergy of specialized AIs working together in multi-agent collaboration, tackling problems that might be too vast or complex for any single agent alone.
Exactly. And these patterns, they're not just theoretical constructs, right? They are the fundamental building blocks for creating AI solutions that are robust, intelligent, and truly impactful. For your profound mission in domestic violence crisis response, these insights will enable you to craft systems that are not only efficient, but also, hopefully, empathetic, precise, and capable of handling the most sensitive and critical situations with a level of sophistication that was previously, well, pretty much unimaginable. You're really moving from just building smart responses to architecting intelligent, potentially self-evolving systems.
So, as you move forward, as you start to apply these insights in your own Python solutions, maybe consider this. How might you combine these agentic design patterns, reflection, tool use, planning, and multi-agent collaboration to build an AI system that doesn't just respond to a crisis, but maybe even proactively anticipates needs, adapts its strategy in real time, and provides a truly multifaceted, personalized safety net for those who need it most? The tools, the patterns, and hopefully a clearer mental roadmap are now in your hands.